Hey everybody, it is Wednesday the 16th. Yesterday you watched a video on substitution.
Teachers, this is a reminder that there is a language arts vertical meeting in Patricia Healy's room right now. So please go to the meeting if you're a part of this. Thank you.
See, I told you it's just like you sitting in class because that was an interruption. But where was I? Yesterday you watched a video on substitution, and today we did some practice. I differentiated and broke you into some groups. Those who understood it got to move on, and those who needed some extra practice worked with me. So here we go. We are now taking notes on our third method. Okay, let me just adjust this a little bit so you're not crooked, or I'm not crooked. So, systems of equations. So far we've done graphing, which is method 1, substitution is method 2. Method 3, you will like. It is called elimination. Elimination. So think about what elimination means. We are going to eliminate something, get rid of something. Okay, now remember, the whole concept of systems of equations is we are trying to find the solution to the system. So what does that mean? Where the two lines intersect on a graph. Well, we don't want to graph these. We are using algebra and other methods. But we want to find the point where the two intersect. Now, with elimination, you want to make sure your equations are in standard form. We talked about slope-intercept form, and we've talked about standard form. Standard form basically looks like this. AX plus BY equals C. A, B, and C are all integers. Okay, so this is what we want. We don't want to solve for y anymore. That was slope-intercept. We want x and y on the same side. So, example 1. I have these two equations. The first thing you want to do is make sure they're in standard form. AX plus BY equals C. They both are. And you also want to make sure everything is lined up. Your x's are lined up, your y's are lined up, your equal signs are lined up, and your constants are lined up. And now that they are, you want to look and say, okay, out of x and y, or x or y, I want to eliminate. I want to get rid of one of them. Because if I get rid of one of them, if I make one a zero pair, then I can easily solve for for the other variable. So, in order for something to be a zero pair, you have to have the number and its opposite. So we need to look at the coefficients. Well, if I look at y, I have a 2 and a 1. Those are not opposites of each other. Here, I have a positive 1 and a negative 1. So if you think about it, if you add a positive 1 and a negative 1, they go away. It makes a zero pair. So if I add these two equations, x goes away. So what does that leave me with? 2y plus y is 3y. 13 and 5 is 18. Well, guess what? You've already solved for y. So y is 6. Now remember, we're trying to find the point. That is just the y coordinate. So now take this, plug it into either one. It doesn't matter, just like yesterday. So I plug it in, and I solve. One-step equation, so x is 1. So the solution to this system, the point where these two lines intersect, is 1, 6. Okay, so let's look at this one. And remember, you can stop this at any point, work on it without me. You can slow it down. Whatever you need to do, and I hope you're nice and comfortable. Some of you are sitting in class, so probably not as comfortable as you would be if you were at home. Okay, so everything's lined up. I want to look for a zero pair. Well, I'm going to get rid of x because one's positive 3, one's negative 3. It goes away. So now I have a negative 1 and a positive 7. That gives me 6y. 30 and 6 gives me 36. And again, that's how quickly you are finished. Plug this back in, either equation. And be careful with your signs, so x is 12. Okay. Here's C. So now you're looking at this and you notice, okay, they're not lined up. So we just have to rearrange them so they are lined up. So I'm going to go over here and rearrange my top one. And remember, this is just the commutative property of addition. I can just flip-flop, but be careful that you carry over the negative because that negative goes with the 3. So negative 3x minus y is equal to 8, and then just rewrite this. And hopefully you see that you want to eliminate y because one is positive, one is negative. So by adding, y's go away. So you get 4x is equal to, be careful of signs, negative 4. So x is negative 1. Now plug it back in, and it doesn't matter what equation. I'm going to plug it in up here. Negative y minus 3 times negative 1. We need to be familiar with these negatives. I could have plugged it in here, and that would have been less negatives, but I wanted you to practice with your negatives. So this really is a positive 3. Get rid of 3. So negative y is equal to 5. I don't want negative y, so I divide by negative 1. So y is 5. Okay, so here we have, it's not in standard form. So you're thinking, well, I'm solved for x, so I can just substitute. No, because then you wind up with a fraction. You need to rewrite this top one and put it in standard form. So move 5y over. So that gives you negative 3x minus 5y is equal to a negative 7. Rewrite this. And then what hopefully you notice by writing it, negative 5, positive 5. That goes away. So you have a negative 3x, a negative 4x gives you negative 7x. Negative 7, positive 14 is a positive 7. So x is negative 1. Plug it back in either equation. And make sure you're plugging it back in for x, because that's what you found. So 4 plus 5y is equal to 14. Get rid of 4. So 5y is equal to 10. Divide by 5. So y is 2. Okay, so I'm looking at this problem and everything is in standard form. And what do I notice? Well, my y is 3 and a 1. My x's are both positive. Okay, so that doesn't make a zero pair. Remember I said at the beginning of the video, you have to have one positive, one negative. They have to be opposites of each other. They're not. Okay, so I can't add them together, because if I add them, I get a 2x. So hopefully by me stressing the word add, you realize, oh, but I can subtract, and if I subtract an x and an x, I get a 0. So I need to subtract these two equations. Now be careful. You guys always mess up with the subtraction stuff. Okay, subtracting is like adding the opposite. So you need to go in, and what I'm adding, or what I'm subtracting, is everything in here. So I need to change everything to its opposite. Every single thing in my parenthesis changes to its opposite. Now I have different signs and my x can go away. So now be careful. A negative y and a negative 3y gives you a negative 4y. Negative 4 and a negative 4 is a negative 8. So the main difference in this problem is this right here. You have to subtract these two, which really means you're adding the opposite. Be careful that this goes in the y spot and you don't accidentally put it here. So now I plug this back in. I'd like for you to stop the video right now and try this one and then start back the video. Okay, so everybody should be pausing the video, doing this one on their own, and then starting it back over. Okay, so you hopefully said, I'm in standard form. I want to get rid of this because it's the same number, but I need to subtract because they're both positive. So if I subtract, hang on, let me make sure I open the door. Sorry guys, I had some people coming in for a test. Hold on one second. Do y'all want to go sit in another classroom, or are you okay? You fine? Okay. Okay, so I believe I said you notice that you need to subtract. So when you subtract, you really change every sign. You're adding the opposite. So now x's go away. -8 positive y is a -7. 36 and -15 is 21. So you get y is -3. Plug -3 in. So what is that, 24? So 6x is equal to 12, so x is 2. Now, what if we had this type of problem? Where are we? Okay, so now I'm giving you a problem. It's in standard form. Everything's lined up, but I don't have anything that has the same coefficient but opposite. I have a 2 and a 1 and a 7 and a 1. Okay, so I can't just add or subtract because I don't make a zero pair. But what I can do is I can say, you know what, I want to eliminate x. So if I want to eliminate x, they have to be the opposites of each other. So what I can do, I can multiply my top equation by -2, and then that will give me a zero pair. But remember, if I multiply one thing, I have to multiply everything. So I'm going to rewrite it. And then bring this one over. And now you notice you have a zero pair, and you can add the two equations. -2, positive 7 is 5y. -4, 9 is 5. So y is 1. Now plug that back in. And your solution is 1, 1. Okay, so here I have two equations. They're in standard form. It's all lined up. But I don't have a variable I can eliminate. So I have to do something to an equation to create that ability. Okay, so if I look, the easiest way to do it is I have 5y and 10y. So what do I want to do? I want to multiply my top equation by a -2. Remember, multiply everything. So -4x minus 10y is equal to -6. 3x plus 10y is equal to -3. So now I have my zero pair, and I have -4x and a positive 3x gives me -x is equal to -9. So x is 9. Plug that back in. Get rid of 18. So 5y is equal to negative 15. Y is negative 3. And last one. Now, hopefully you look at this and say, wait, we just did this one. Right, so you know what the answer should be, but I don't want you to eliminate y. I want you to eliminate x. So hopefully you're already thinking, okay, I've got to get rid of x somehow. One's a 2, one's a 3. Okay, we're not going to divide. We're not going to multiply by a fraction. We're not going to multiply by a decimal. Okay, always multiply by integers. So you're looking at 2 and 3 and think, okay, how am I going to make them the same? Okay, so we need to get them the same. So how do I do that? Hang on a second. Okay, I look for the least common multiple of the two. Well, if I have a 2 and a 3, I know the least common multiple is 6. Okay, so you think, well, what do I have to multiply the 2 by to get 6? 3. What do I have to multiply the 3 by to get 6? 2. Now, let's do this in one quick step. If I multiply this by 3 and this by 2, I get a 6. But remember, one has to be negative. So choose one to be negative, and it doesn't matter. So now, rewrite them. And now you have a variable that you can eliminate. So we're adding and they go away. So when I add this, I get negative 5y is equal to 15. Y is negative 3. Verify, is that what we found? Yes, we did. So obviously we did it right. So now plug in negative 3. So 2x plus negative 15. Get rid of 15. So 2x is equal to 18, so you know x is 9. And I forgot to write my ordered pair. Okay. Again, you can go back and replay any of this to make sure you understand it. Okay. Now, here are your try-Ds that I talked about. Okay, so now you're going to do these 4 try-Ds in your composition book and bring them to class tomorrow. Okay, I'm going to go, you can pause this and finish writing them, but I hope you guys have a great night and I will see you tomorrow.